What is the question given? Find VTH and RTH. Nothing but Thevenin's voltage and equivalent resistance without load, and the load current and load voltage flowing through RL. Here we should find current through RL and voltage across RL as shown in the figure by using Thevenin's theorem. Now what we want to do, we should convert this circuit into this form of circuit. Nothing but VTH and RTH along with the load resistance. So the circuit is converting into this circuit, this simplified circuit. So the circuit is going to simplified into Thevenin circuit. First step is we want to calculate VTH. So calculate VTH by removing load resistance. Removing load resistance. VTH. Here we want to calculate VTH. We want to calculate between A and B. So this is between A and B. By removing RL. If we draw this circuit, then the circuit look like this. So we want to calculate VTH by removing RL. So the simplified circuit look like this. You can use any one of technique to find VTH. So I am taking mesh analysis. For mesh analysis we need loop current. I am considering this as I1. Here it is not a loop, then there is no loop current. So from mesh analysis, taking loop 1, from loop 1, 12 plus 4 16 I1. Here I1 touching first negative terminal, so minus 48, which is equals to 0. Again 16 I1 is equals to 48. 16 3 ja, which is 48. So I1 is equals to 3 amps. So now I am taking voltage across this 4 ohms is V1. Now V1 is equals to this current into this resistance into 4, which is equals to 12 volts. V1 is equals to 12 volts. Hence there is no loop here. So voltage across 4 ohms is equals to voltage across these terminals. So VTH is also equals to 12 volts. Is this 12 volts or not? We are checking with the nodal analysis. The obtained Thevenin's voltage is correct or not? We are checking with the nodal analysis. I'm taking current directions like this, current flowing away from the node. So now V1 minus 48 by 12 volts, 12 ohms, plus V1. I'm taking this as a reference node. So V1 minus 0 by 4 ohms plus V1 minus VA by this 8 ohms, which is equals to 0. If we take 4 as common, then we are left over with here 3 1 2. From 3 1 2 we get 6 as LCM. So we are considering below as 6 plus by 6, which is equals to 0. 3 2 is 6. So 2V1 minus 96 plus 1 6 is 6. So 6V1. 2 3 is 6. So 3V1 minus 3VA, which is equals to 0. Taking 6 as common and sending to other side. So this 6 is going to cancel. Now we are left over with 2V1 minus 96 plus 6V1 plus 3V1 minus 3VA, which is equals to 0. Here I am writing V1 as common. So 2 plus 6 8, 8 plus 3 which is 11V1 minus 3VA. I am sending this 96 to other side, so 96 is equals to 96. To solve this equation we need another equation which contain with V1 and VA, but here we have choice of calculating V1 by using mesh analysis. V1 minus 48 by this 12 is equals to I1 from mesh analysis. Why it is coming big values? Let us check once. Here V1 minus 48 by 12 which is equals to I1. Sorry, here we want to take minus I1 because we are taking opposite direction of this current, so minus sign we must take. So here minus 3 which is equals to minus 36. Now here we are getting 12. So I'm sorry in writing this equation. So if we substitute V1 in this equation, take this as equation 1. You substitute V1 in this equation, so 11 into 12 minus 3VA which is equals to 96. Now minus 3VA is equals to 96. 12 11 12 which is 132, so minus 132. Now VA is equals to 12. Here we get VA is equals to 12 volts. Now VA is not a VTH. What is VTH? VTH is equals to VA minus VB. We are taken VB which is equals to reference node, so VB is equals to 0. Now VA is equals to 12. Now VTH is equals to 12 volts. Hence from mesh analysis and nodal analysis we obtained VTH as 12 volts. Calculated by, now we want to calculate by removing load resistance and replacing sources with their internal resistances. Now calculating RL by removing RL. So we are removing RL, this is A and B, and replacing sources with the internal resistance. Here we have voltage source. If we replace with internal resistance, here we obtain short circuit. So here we obtain short circuit between these. We want to find the equivalent resistance between this A and B. So we want to calculate equivalent resistance from this direction. So from this direction we want to calculate equivalent resistance. To calculate equivalent resistance from this direction we should come from opposite direction. So these two are in parallel. Now here R is equals to 3. So if we draw the circuit looks like this. Now these two are in series, nothing but 8 plus 3 which is equals to 11 ohms. Third step, draw the circuit with VTH, RL, RTH and RL equivalent circuit, simplified circuit. So the circuit looks like this. VTH which is, now here VTH is obtained 12 volts, RTH is obtained 11 ohms and RL is given as 5 ohms. Here he was asked to calculate current through 5 ohms resistor and voltage between this load resistance. And voltage between this load resistance. If we write loop equation, then we get 11 plus 5 which is 16, I which is minus 12 is equals to 0. 16I1 is equals to 12. I is equals to 12 by 16. Is equals to 0.75 ampere, 3 by 4 amp. So current through 5 amps is 3 by 4 ampere, 0.75. V is equals to IR. Hence we want to find voltage across this 5 ohms and current through 5 amps and resistance is 5 ohms. Resistance is 5 ohms is simply 5. Current through this 5 ohms is 3 by 4, which is equals to voltage through 5 ohms is equals to 3.75 volts.